Welcome back to some more geometry. Let me close this out real quick. Today, we're talking about geometric means. Oh, man. All right, there we go. So yesterday we talked about radicals and simplifying radicals. So we're going to run into some of those radicals today. So that's why we took the time to discuss radicals. Quick review on radicals. Remember, when we're simplifying radicals, we want them at their lowest form. So for example, when we had radical 28, that doesn't have a perfect square number. It's not a perfect square number. So a number in 28 does. It's 4. So we split this up to be radical 4 times radical 7. Okay, and then radical 4 does have a square root, the value of 2, so it comes out of the radical. And then 7 doesn't have one, so it stays under the radical. All right, so lead on. So when we talk about means, we're talking about the average. So when we've done arithmetic means, those are the means that we're used to doing. We just call them averages. Okay, that's the average by taking two numbers. So for example, 2 and 8. And we add them, and we get 10. And then we divide it by the number that we added all together. So we had 3 numbers, we divide by 3. We have 4, we divide by 4. In this case, we have 2, so we're dividing by 2. So 10 divided by 2 gives us 5. So that's the arithmetic mean of these two numbers. But the geometric mean, let's talk about that. That's a little bit different. So here we're taking that same 2 and 8, and it's 4. Well, how do we get 4? It's a good question. So we got 2 times 4. We're going to multiply them, and then we end up getting 16. And then from this point, we're going to go ahead and square root them. So instead of dividing, we're square rooting. The square root of 16 is 4. And that is our geometric mean. So that's how we'll be doing our averages. That's the whole point of this is geometric mean. But again, we're going to be setting them up in a proportionality kind of style. Sadly, one of the chapters that we skipped that we'll come back to talked about proportionness, like proportionality. So that's how we set it up. So here, when we set these up, we have our a over x and our x over b, where our two middle values, in this case the x, the same one, those are our averages. Those are our means. That's what we call them, means. But the other two numbers, in this case a and b, those are what we call extremes. Extremes. Now the reason they're called extremes is because they tend to be the smallest and biggest value in our problem here. That means our means are the average in between there, and these are our smallest and biggest numbers in our problem. So let's look at this first one right here. We're going to do this together. So we're going to find the geometric mean of 2 and 7. Now, realistically speaking, you can just multiply them and square root them. But we're going to set them up in the proportionality style here just to kind of get used to that. So here we'll do 2 over x is proportional to x over 7. We cross multiply. We end up getting x squared equals 14. And then we will square root both sides. Square root, square root. We end up getting x equals radical 14. Now, the reason it's radical 14 is because we have to leave it like that, because there is no perfect square root for 14. Remember, the factors of 14 are radical 2 and radical 7, and that doesn't help. So we leave it as radical 7. And since we are been really good about radicals, we're going to leave it in radical form. Unless it specifically tells you round it to the nearest decimal, we're going to leave it in radical form. So go ahead and pause and take a minute to do this on your own. Hopefully you did do it. Let's see if you set it up right. So the first part, we're going to get our 4 over our x, and that should be proportional to x over 16. We cross multiply here. We end up getting x squared equals 64, and then we square root both sides. Square root, square root. Square root of x squared is just an x, and the square root of 64 is 8. So hopefully we got the same answer. You got an 8. All right, so again, geometric mean. So we're doing average, but not just a random numbers. We're doing the numbers of some geometric figure. This is the figure we're talking about. So here we have a right triangle, okay? And now this theorem is just talking about how we created two smaller right triangles. But let's see what's important about that. So you're going to draw an altitude that goes from the right angle down to the hypotenuse of the triangle. By doing so, this is our altitude right here. Altitude right there. When that was drawn, it divided the triangle into two smaller triangles. So it divided the side and the triangle. But when it divided this triangle, it created two similar triangles such that all the parts in this triangle are not only proportional to the other triangle, so the other small triangle, but both triangles are proportional to the main original one that they divided into. So if C is the hypotenuse of the big one, that's proportional to A, which is the hypotenuse of the small one, and that's proportional to B, which is the hypotenuse of the bigger of the two small triangles, which that's proportional back to the original triangle. So it's one big circle between them all. A is also proportional to C, B to C, and then B to A, and A to B. So they're all proportional to each other because that's what this is. That's what makes them similar. They're proportional in size to each other. Compared to all the sides as well. They're proportional to each other's counterparts. So this first theorem kind of relates to what happens with the altitude. So this is called a geometric mean altitude theorem because when the altitude was drawn, so we're specifically talking about the altitude is the geometric mean here in this case, because when this altitude was drawn, it split the hypotenuse up such that the individual segments are proportional, or not proportional, but makes the z the geometric mean, meaning x and y are the extremes here. So that says, so when you set it up, you say, hey, the small segment is over the altitude as the altitude is over the other segment. So that's the proportionality that happened here. So if you look at this triangle, you want to talk about like even more specific, like really get to the nitty gritty here. We say, hey, look at this small triangle. Here's the small leg and long leg. Okay, if I were comparing this small leg to this long leg, I'm going to compare it to the other one, which makes then z the small leg and y the long leg. So that's how the proportionality works. Small leg to long leg, small leg to long leg. But more realistically speaking, the best way to kind of remember is like, hey, z is the geometric mean of the two segments. So that means the two segments are my extremes, and then the altitude is my means here. So let's kind of practice that, see how that's going to be used here. In this first problem, they let us know that this small segment is 2, and this bigger segment is 8. We are looking for the altitude here. Well, let's set it up. Like we said, small segment to altitude. So 2 is to z, as the altitude is to the longer of the segments, 8. We cross multiply. We end up getting z squared equals 16. We then go and square root both sides. We end up getting z equals 4. That's my geometric mean. So, and of course, that value has to be in between those two numbers, 2 and 8, because it's the geometric mean. Let's try that one more time. Hopefully take a pause, look at the first one, and then try this on your own. Okay, I'm going to put in these numbers in to see if we can guess it before I get done. So I'm going to say x right here to tell us x is 4. Z this time to give us the value 6, and we're looking for y. Again, the setup is still the same. Segment to altitude, altitude to segment. So segment to altitude, 6. That's proportional to 6, and the other segment, y. We're going to cross multiply here as well. We end up getting 4y equals, I keep making my 4s kind of weird. 4y equals 36. We then divide by 4. Divide by 4, we get y equals 9. Now somebody asked, like, well, why didn't we square root? You only square root when you have to. Here, because we had a z square, we square root here. We only have one unknown, no y squared, so we just divided to get y by itself. So you should got 9. All right? All right. So the other geometric mean that we're going to do, as you saw, so backtrack, quick review, as you saw, at no point did we ever use A or B. Yeah, no, because they don't have no relationship like these two segments do with the altitude. So that's why it's related. This next one, though, does involve A and B. We call these the geometric mean leg theorem. So the leg theorem says same way, kind of the thing. The legs are the geometric means of certain parts. Let's see the parts. So we have this small triangle. I'm going to color code these so we know what we're talking about, which triangle we're talking about. We got the bigger of the two triangles, and then we have the original triangle. Right there. All right. So here we're saying C is to A. So C in the original triangle is our hypotenuse. So the hypotenuse is to A. A in this case in the original triangle is the short leg or SL. Small leg, short leg, however you want to do it. So HL. Let me move this over. Kind of lost in the blue. So HY, representing hypotenuse, is to his short leg, as since we're talking about A, we got to use this triangle now. We're comparing the parts of this triangle to the original one. A, in this case, now becomes the hypotenuse of the short leg, and then X is the hypotenuse of the small triangle, and X represents the short leg of our small triangle. And that's one problem. Understand, these are two separate problems, so don't let it like confuse you. You're either going to do this or you're going to do the other proportion. I just set up the two proportions so we can see how they compare to the original one. So let's look at this next one. Here we're saying, hey, we got our hypotenuse. Let me make sure we color code this right. Our original hypotenuse to now B. B represents then the longer leg of the two, so the long leg. That's proportional to B is now the hypotenuse of the smaller triangle. So again, gotta color code those correctly. Blue, hypotenuse of the smaller triangle, and Y is my long leg of the smaller triangle. And then we cross multiply and divide again. That makes B the mean, the geometric mean, and both of them, that makes A the geometric mean. So the legs in this case are the geometric mean between all these right here. Let's try this out. So here, first one, this first problem, they tell us that C is 29 and X right here is 3. And we're looking for A. So that means we're dealing with this small triangle right here, the parts of this small triangle. All right, so let's kind of set that up. Like we said, we do, since we're doing with a small triangle, we do hypotenuse to small leg. So hypotenuse of the big triangle is 29. The small leg, in this case of the big triangle, is what we're looking for, our A. That's proportional to the hypotenuse of the small triangle, the A, over its small leg, in this case 3. So we cross multiply, we end up getting A squared equals 87. And again, to get rid of the square, we square root both sides. So we square root A squared, we end up getting just A, and then we square root 87. It stays like that because it does not simplify. It's not a pretty radical, so we're just going to leave it like that. All right, so take a pause. Try the second one. Try the second one on your own. I'm going to erase this. Hopefully you paused and tried it out, and I'm going to go for it now. So hopefully you said it right. Let's put in the part we know. We know the hypotenuse of the original triangle is 18, and we know that its long leg is 12 radical 2. And then we're looking for the long leg of the small triangle. Question mark, question mark. All right, so as we go to set it up, same thing. We're doing, like we did before, we're doing hypotenuse this time to long leg. So the proportionality goes 18 to 12 radical 2. And then that's proportional to the hypotenuse of this triangle over here, which in this case is the B, or 12 radical 2, to its long leg, which in this case is the Y, what we're looking for. We cross multiply, we end up getting 18Y equals 12 radical 2 times 12 radical 2. So a lot of people ask this question, like, how do you multiply this with the radical? Well, good question. That's a really good question, honestly. We're going to multiply outside numbers with outside numbers and radical numbers with radical numbers. When that happens, we still got our 18Y, but now we end up getting 12 times 12, 144, and then radical 2 times radical 2, radical 4. Now, we spent all day yesterday working on radicals. Radical 4 does have a value. It's 2. That becomes 2. And we still have that 144. So when we multiply these two, we end up getting 288. And we still, of course, this all equals 18y. We divide both sides. Hopefully you did it correctly. You get y equals 16. That's all your assignment for today. Hopefully that helps. You guys have a good rest of your day. Bye.